All right. Good evening. Welcome to lesson 10-4. I'm having a little trouble being tongue-tied today. I'm sitting here with my good friend Quinque, and we're going to help you be introduced to three-dimensional space figures. And now, space figures does not mean like these are figures that are out on the International Space Station, although they could be. What I mean by space figures is three-dimensional objects. Are you ready, Quinn?
Yeah.
All right, cool. All right, so now space figures break into three main types that we're going to talk about. There are other types floating around, but we're going to talk about cylindric surfaces, conic surfaces, and spheres. Okay? So those are the three main types. And I'll just really quickly clue you in. Cylindric surfaces means like a cylinder. It doesn't necessarily mean it's round in any way, shape, or form. Okay, so in fact, we're going to see that prisms are included in cylindric surfaces. Likewise, conic surfaces means like a cone, but it doesn't have to be a cone. It can be a polygon on the bottom. And spheres are basically balls. You know what spheres are. We're just going to get a little bit more mathematical with them. And for all of these, one of the big challenges, in addition to the vocabulary, is going to be learn how to draw these things. So it, in some way, shape, or form, conveys an optical illusion of being a three-dimensional object. Because you got to remember, I mean, you're looking at a flat video. When you do your homework or your classwork, you're going to be drawing on flat paper. So anytime we draw a three-dimensional object, what you're trying to do is it's kind of like art class. You have to kind of draw a perspective and try to make it look three-dimensional. So that is going to be one of our big challenges. All right, let's dig into the three types. First, we have cylindric surfaces, and they come from two types. One is the namesake, like a cylinder. So let's go ahead and start with a cylinder. Very often what we do is we draw dotted lines to indicate things that are in the background that we can't see. And we always draw three-dimensional objects like we're kind of a little bit above them and we're looking at them kind of in an angle. Because we know that the top and the bottom are what shape? Like, if you look straight down, it'd be a perfect circle, right? That's not what I drew. I drew an oval because I'm looking at it from the side, okay? So that is a cylinder, and a cylinder is what you get if you start with a circle. Oops, there's supposed to be an N. My stylus is not cooperating. Sorry about that. But a cylinder starts with a circle that you lift straight up into the air, okay? And you end up getting two circles that are congruent, and they're in parallel planes, okay? And that's a cylinder. Now, if I start the same thing, let's start with a triangle and go straight up in the same way. Okay, and I've already kind of broken my rule, so let me back up. Let me start with the top triangle. So let's go ahead and start with the triangle. And let's make this into the same kind of figure. So we're going to make a dotted line. Whoops, dotted line going down. And again, I have two parallel bases. Okay, but instead of circles now, they're triangles. And so this is a prism. And this one in particular is a triangular prism. We name prisms after their bases. So whatever shape the base is, that's what we're going to call it. So if it's a rectangle, it'll be a rectangular prism. If it's a square, it's a square prism. If it's a pentagon, it's a pentagonal prism, and so on. Okay? And the reason that prisms are called cylindric is because, except for the fact that they're not round, it's the same basic idea. You start with a shape, you lift it into the air to another parallel plane. Both of your bases are going to be in parallel planes, and the bases of the cylinder are circles, and the bases of the prism are going to be the triangles. By the way, bases does not mean anything about top and bottom. I could just as easily have drawn a prism laying on its side like this, kind of like a tent, okay? And the bases still would be the triangles. The bases are the sides that are not rectangles. Yeah. Okay? All right. So the other type of surface, again, we're going to start with a circle. So let's start with an oval. This time we're going to go up to a point. Okay? And it looks kind of like a teepee or an upside-down snow cone, and that is exactly what it is. It is a cone. Again, if we look straight down on the top, it would be a circle, and it goes up to a single point, which sometimes is called the vertex point, just like in a triangle, okay? And if we start with a polygon, let's start with a rectangle this time, and I'm going to break my rule. I'm not going to draw dotted lines this time. But there you go. Start with a rectangle and go to a point, and that's called a pyramid. And just like with prisms, pyramids are named for their bases. So this one would be called what? What kind of pyramid? Starts
Square.
with a... Well, square if it was. It looks like this one's kind of more of a rectangle, right?
Yeah.
So I'd say it's a rectangular prism. A square pyramid would probably look more like this. Okay? And somehow you'd probably try to indicate that your sides were all equal and that maybe you had a right angle down there. And then you've implied that it isn't square. And so this one would be a square pyramid. This one, the first one we drew, was a rectangular pyramid. Okay, now the last figure that we're going to talk about is a sphere. And to draw a sphere is a little bit tough. You start with just a plain circle, and to try to make it look three-dimensional, what we try to do is we try to make it look like a globe. So we're just going to give it an equator that goes around the middle. Okay, and it's not perfect, but it kind of conveys the idea that, hey, wait a second, this is actually popping out at us a little bit. Okay, and that's a sphere. A sphere is a little bit interesting because we start with a circle, and instead of lifting it up like we do in a prism or a cylinder, or lift it up to a point like we do for a cone or a pyramid, we're going to take that circle, and what we do, and actually it kind of looks like the picture, is we actually spin it around on its axis. And that makes a sphere. Now we know spheres all the time as things like balls, basketballs, baseballs, racquetball, ping pong balls, anything like that. Any kind of ball, tennis ball, is a sphere. All right. All right. Now, suppose you have to make one of these things, and I give you like an old pizza box, and I give you some cardboard, and I give you some scissors, and you have to try to cut out a two-dimensional shape that's going to fold up and turn into one of these space figures. Okay, well we have a name for that. It's called a net. Okay, and so a net is going to be the 2D shape or shapes that you would cut out. So 2D shapes cut out to make a space figure. All right, so let's take an example. Probably one of the most common ones. You've probably seen this before. If you ever played one of those cereal box games, you know, like they have a board game on the back, and they tell you to cut out and make your own little die. Okay, and what they'll do is to make the die. A die is a cube, right? They'll have like this long strip, and on the strip there'll be sides that are squares, and there'll be numbers on them. And a lot of times there'll be another square sticking up here, and there'll be another square sticking out here, and then there might be some glue tabs that you kind of that it has, so you can kind of put the thing together. They're not actually part of the figure. Let's go ahead and put another one in there. But they're going to be helpful if you're actually gluing the thing together. But these are the sides. And so maybe this is 1, and this is 6, and this is 2, and this is 5, and this is 3, and this is 4. And that's a real die because it turns out on a real die, the numbers on opposite sides will always add up to 7. So that if you actually fold that up, now picture this cut out, you would wrap this side. Oh, I probably should put a glue tab here too. You'd wrap this side around to here, correct? And that would make a square, and then you flop down the 1 on the top, and you flop down the 6 on the bottom, and you tape it or glue it all together. If you really want to have a good tab, you might put tabs there too. Okay, and that'll fold all together. And so you could actually make a cube out of that. This thing is called a net, and again, it's the two-dimensional figure that you cut out, fold it up, and turn it into a three-dimensional object. Pretty straightforward, right?
Yep.
Okay. The last part is let's take a look at 3 nets. And let's think about if I cut these out and I fold them up, what I would get. All right, so Quinn, actually everybody, quickly pause the video for just a second. And I want you to look at these 3 nets, and I want you to picture them cut out. And I know they're not perfect, but imagine cutting them out and then folding them up and tell me what figures you get. Remember, your choices are cylinders, prisms, pyramids, cones, and spheres. Okay, I think it's pretty obvious none of those are going to be a sphere. It's very hard to cut out a two-dimensional shape and make it into a sphere. All right, so pause the video. Try to come up with actually physically write down what you think these 3 shapes are going to turn into, and then resume the video. All right, so the first one, Quinn, if I fold that up, what am I going to get?
A triangular pyramid?
Yeah, it's going to be a triangular pyramid. It's going to be like that one I drew. Okay, it's going to have fairly tall sides. It's going to look something like that. Okay, the next one is going to fold up to what?
A triangular prism?
Right, a triangular prism. So it's going to have triangles on the end. It's going to go across like this, and there'll be a dotted side in the back. Okay, and then the last one.
A cylinder.
Yeah, it's a cylinder. So it's got a circle. It's got this big long rectangle that wraps all the way around, and then it's got a bottom. So that would be kind of like one of those little mint things, like those icebreaker mints.
Oh, yeah.
Yeah, or a hockey puck. Okay, except it's hollow. Okay, so that's exactly right. So this one gave us, the first one gave us a triangular pyramid.
Yeah, pyramid.
The second one gives us a triangular prism, and the third one gives us a cylinder. Okay, and the ones with circles, since circles and cones always start from circles, we don't have to say two names like we have to do with the prisms and the pyramids. Okay, folks, that's it. We're going to try to keep it under 10 minutes, so thanks for watching. We'll practice these in class.